Look at the directions. It says given below, very interesting question type, right? It says given below is a representation of the percentage of area of a sheet of paper with area 2000 centimeter square used to form different figures. Right? So try and understand the data first, and then I'll present the questions, right? There are 5 questions given along with this data, but let's understand what is given here. It is very, very important that when you're answering questions from data interpretation, when you're solving questions from data interpretation, then you got to understand the data first. You should realize what all can be extracted from the given data. Here we have just one simple pie chart. Now what does this pie chart talk about? It talks about the percentage of area of a sheet of paper with area 2000 centimeter square used to form different figures. So if you see different figures have been formed here. I mean, in the pie chart you can see he's talking about a cone, a cuboid, a square, isosceles triangle, and a circle, and the percentage distribution is given to us. Right? And he's also mentioned that the total area of the sheet of paper is 2000 centimeters square. You understand? So if I have to help you understand this, there is a sheet of paper. The total area is 2000 centimeters square. Right? The total area of this sheet is 2000 centimeters square. Now we have formed different shapes from the sheet of paper. Right? There is a circle. There is a circle which has been cut out, and this circle takes how much of area? 30.8% of the area. Then there is an isosceles triangle, right? We have also cut out an isosceles triangle. The area covered is only 3%. Then there is a square which has been cut out, right? It is 8.45%. It occupies 8.45% of what? See, all these percentage would be with respect to 2000 centimeters square, right? The total for this pie chart is 2000 centimeters square. Then there is also a cuboid which has been cut out. Now you cannot make a cuboid from a sheet of paper, but yeah, they have taken different pieces of. Now what is a cuboid? A cuboid is nothing but a rectangular box. So they have taken 6 different rectangular pieces and made a cuboid out of it, right? I mean, cuboid, you know, is a 3D figure, right? This sheet of paper is 2D, but they can take different pieces and make a cuboid out of it. So 2 rectangles of this shape, maybe 2 rectangles of this shape, and 2 more rectangles to get a cuboid there, right? You know that a cuboid will have 6 faces, right? So these 6 faces can be cut out and then formed together to get a cuboid. And then there is also a cone, and cone here is he's talking about curved surface area of a cone. So curved surface area of a cone, you know that a curved surface area of a cone would be like a, like this, right? So you join the 2 edges to get a conical shape, right? A conical shape. And he's only talking about the curved surface area. So the base of the cone has not been formed. Only the conical structure has been formed from the sheet of paper. And of course, when you're trying to make different faces, some percentage of area will be left out. See, all this remaining area is something that has not been used from the sheet of paper. See, one important point to be noted is usually when you sum up the percentages in a pie chart, it should add up to 100. But here, if you quickly look at it, it is not adding up to 100, right? 30.8, 27.5 and 25. That is roughly about 82, let's say. 82 and 8 is like 90 and 93. So somewhere around 7% of the area is missing. What is that 7% approximately? That is a unused area, wasted paper. You getting me? The full paper has not been used in making shapes. Some paper has got wasted. Very, very important observation. If you miss on that, then you will you may get confused or you may get wrong answers, right? Remember that there's some unused area which has not been mentioned here. Add it up. 27.5 plus 25 is 52.5. 52.5, let's say this is 8.5 approximately. 52.5 plus 8.5 would be 61. 61 plus 3 is 64. 64 plus, let's say 31. That's like 95. So somewhere around 5%, right? Roughly about 5-7% is lost. Yeah, roughly about 5 to 7% is lost. So that's the unused area. So there is also some unused area. Remember, there's some unused area, unused paper or wasted paper. And we will deal with it as and when the question demands. Okay, so basically we have understood that from a sheet of paper different shapes have been cut out, and we have been given the percentage area occupied by each of these shapes, and all these percentages should be taken on 2000 centimeters square. Now it's very important that you do these calculations quickly, right? I have mentioned always that you have to be very quick in your calculations. You have to do your numerical calculations mentally as much as possible so that you can avoid wastage of time in the exam, right? Like for example, 25% of 2000, that's very easy. 25% of 2000 is 500. Yeah, 27.5% of 2000, how much will that be? See, 25% is easy to calculate. 25% is what? 1/4 of 2000. 1/4 of 2000 is 500. How about 27.5? It's all about split and merge. I would say 27.5 is 25% plus 2.5%. That makes the calculation really easy. 27.5 is 25 plus 2.5. Now we have already calculated that 25 is 500. If 25 is 500, 2.5 will be 50. Yes or no? If 25% is 500, 2.5% would be 50. So 500 plus 50, 550, which means the area occupied by the curved surface of the cone is 550. See, I'm explaining, so it's taking so much of time. When you do it yourself mentally, it should happen very quickly, very rapidly in your brain, that 500 plus 50, 550 will be the value here. You're getting me? 3%. 3% of 2000, very easy, 60. 1% is 20, 3% would be 60. 30.8%. Calculate 30.8%. See, 30% first. 30% is 600. All about breaking it up, right? 30.8 is not 30.8. It is 30 plus 0.8. So 30% is 600. How much is 0.8%? 1% would be 200. 0.8% will be 160. Sorry, 16. You understand? 1% is 20. 0.8% would be 16. So 600 plus 16, 616 will be the value. So 616 is the area occupied by the circle. You're able to follow. Break it up. 30.8 is 30 plus 0.8. 30% of 2000 is 600. 0.8%. 1% is 20. 0.8 will be 0.8 of 20, which comes out to be 60. Right? So this comes out to be 616. How about square? 8.45%. Now do this calculation. See, you must be capable of doing these calculations really quick. Otherwise, it gets very difficult, right? I mean, time consuming basically. All of us can find out what is 8.5% of 2000, but how quickly do you find it out is the question here. Now 8.45, there are different ways to take it up, right? I mean 8.45, I would take it as 8 plus 0.5 minus 0.05. Easy percentages, right? 8%, 1% is 20, 8% would be 160, 0.5%, see 1% is 20, so 0.5 is 10, 0.5% is half of 1%, right? 0.5% is half of 1%, 1% is 20, half of 1% will be half of 20, which is 10. If 0.5% is 10, 0.05% will be 1. So 160 plus 10, 170 minus 1, 169. So this is 169. Or there can be other ways also to calculate. Whichever method you follow, the point is you should be doing the calculations very quickly, right? You should be able to arrive at the values very quickly. So we know the different values there. Yeah. So note it down. I mean, when you are when there is only one pie chart involved, I would say very quickly find out the values and use this as and when required. And you can also find out the remaining area now. 2000 minus all these values will give us the remaining area, right? Or the percentages can be summed up, and then 100% minus the sum of all these percentage will give us the percentage of remaining area. Okay, so your choice there. Anyway, so that's the data here. Let's look at the questions now. So the first question based on this data is on your screens. Direction is the same. We have a representation of percentage of areas which has been taken from a sheet of paper of total area 2000, used to form different figures. So that's there. Now the question here is this: if the radius of the cone is half the radius of the circle, find the height of the cone. If the radius of the cone, so there is a cone involved here and there is a circle involved here. So he says the radius of the cone is half of the radius of the circle, find the height of the cone. I'll leave you with this question for 1 minute. It's all about using the right formula. See, when it comes to mensuration, it's all about the formula there. You must know all the formula involved, right? Formula for area, formula for volume, formula for surface area, for all these different types of shapes. Circle, square, triangle, cuboid, cone, cylinder, right? Sphere, hemisphere, all the different shapes there. Square, rectangle. Here it's an isosceles triangle, right? It could be a scalene triangle. It could be a equilateral triangle, right? So you should be very thorough with, you should be thorough with all these formulae there. So assuming that you know the formula, I'll give you maybe a minute to try this. The clock starts now. Let's see how many of you get the right answer. We are supposed to find out the height of the cone. What is going to be the height of this cone? Quick. Here's the solution. See what it says. Now the question says that if the radius of the cone is half the radius of the circle, find the height of the cone, right? So we are supposed to find the height of the cone. H is equal to what? Now what is the equation given in the question? That the radius of the cone is half the radius of the circle, right? Let's first work on the circle, right? Circle. Here we know that circle is 30.8% of what? 2000. Remember the total value is 2000. Now what is 30.8% of 2000? We had calculated this, right? 600 plus 16, 616, right? 616. So basically area of the circle is 616. Right, area of the circle is 616. So first step is I'll try and find out the radius of the circle. Once we get the radius of the circle, we can get the radius of the cone, because radius of the cone is half the radius of the circle, right? So first step is to find out the radius of the circle. Try to do that. So I know that pi r squared is equal to 616, or pi can be taken as 22 by 7. 22 by 7 into r square is 616. Now simplify this to get the radius of the circle. Is 616 divisible by 22? I think this is 660 minus 44, right? 660 minus 44. Yeah, and I think that goes 28 times. Yeah, 660 minus 44. So 30 times minus 2 times. 30 times minus 2 times, 28 times. So r square basically is equal to 28 into 7. 28 into 7. Or this can be actually taken as 4 into 7. 28 is 4 into 7 and then 7. So r square is 4 into 7 into 7, which means r will be equal to what? 2 into 7, 14. Or 4 into 7 into 7 is 196. Square root of 196 is 14. Otherwise, square root of 4 is 2. And square root of 7 into 7 will be 7. 2 into 7, 14. Anyway, radius of the circle is 14. Getting it? The first step, I'm not spending too much time on calculation. I'm sure you can do it yourself. We have found the radius of the circle. It comes out to be 14. The question says the radius of the cone is half the radius of the circle. So what is going to be the radius of the cone? Half the radius of the circle. Half of 14. Half of 14 is 7. Remember, you don't have to write this step in the exam. Don't write half of 14, 1 by 2 into 14 equals to 7, radius of cone and all that. I am writing it here so that you can follow. But when you do it yourself in the exam, you know that radius of the cone is going to be 14 there. So don't waste your precious time in the exam, right? During the exam. Anyway, radius of the cone is 14. Now, we are supposed to find the height of the cone. What else do we know about the cone? We know the curved surface area of the cone is 27.5%. How much is 27.5% by the way? 25%, 550, right? 550. Yeah, we had done this, 550. Now, what is curved surface area of a cone? Curved surface area of a cone is pi RL. Again, this is the formula that you need to remember. Otherwise, it's going to be difficult. Pi into R into L, where R is the radius of the cone and L is the slant length, right? So let's simplify this. So basically, curved surface area of the cone, 22 by 7. Pi is 22 by 7. Radius of the cone is 7, right? 22 by 7 into L is equal to 550. Right, curved surface area is 550. Simplify this, 7 and 7 gets cancelled. 22 goes how many times here? 25 times. Right, 55 by 2.2 or 550 by 22 is 25. So L is equal to 25. L is equal to 25. Slant length. Now understand the slant length L. Again, don't write all these words in the exam, right? Don't waste your time. Slant length L for a cone, slant length L is equal to root over R square plus H square. Don't ask me how and all that, right? These are standard formulae you got to learn by heart. Of course, you can also derive the formula, but no point in doing that now. Now, we know the slant length L is 25. We also know that the radius of the cone R is equal to 7. Can you not find out H? Very easily. So, substitute. Take square on both the sides. I mean, squaring on both the sides. What do we get? We get L squared equals to R square plus H square. So, I can say H square equals to L square minus R square. What is L square? 25 square. What is R square? R square is 7 squared, right? So 25 square minus 7 square. 625 minus 49. 625 minus 49 is 576. So H square is 576. H will be root of 576. See, all these steps have to be cut down, right? I'm just writing more number of steps so that you can follow easily. But when you do it yourself, you have to cut down the number of steps that you put on paper. Answer is going to be option 3, 24 centimeters. 24 is the final answer, right? 24 is the final answer. So what are the steps? First step, find out the radius of the circle. You know the area of the circle. Based on that, get the radius of the circle. Once you get the radius of the circle, you can get the radius of the cone, because radius of the cone is half of radius of the circle. Yeah. Once you get the radius of the cone, using the curved surface area of the cone, find out the slant length. And once you know the slant length, from that you can find out the height, as discussed here. So 3-4 steps involved. It would take some time as in about, maximum about 1 minute, not more than that. You have to be very sharp and very quick in your calculations for that. Amanjot Singh says, I always skip mensuration based questions in the exam. No, you should not be doing that, Amanjot, because you see these days more and more questions are being asked on these kind of topics. You never know. In your exam, maybe they will ask 0 questions on mensuration, but how do we know that? You have to be prepared for everything. Anyway, the next question is on your screens now. It says the second longest side of a cuboid is its height. If the length of the cuboid is 15 centimeter, and the sum of the length, breadth and height of the cuboid, which are all integers, is 3 more than half the perimeter of the square, what is the height of the cuboid? All about those formulae there. Use the formulae, solve the equations, and find out the missing variable. So let's take it up now. Here we go. The second longest side of the cuboid is its height. Second longest side is its height. If the length of the cuboid is 15 centimeter, and the sum of the length, breadth and height of the cuboid, which are all integers, is 3 more than half of the perimeter of the square, what is the height of the cuboid? So here again a question is based on height. We are supposed to find out the height of the cuboid. What do we know? The height of the cuboid, according to this question, is the second longest side of the cuboid. See, a cuboid will have three different dimensions, right? Length, breadth, and height. So height is the second longest side. So obviously longest is length, second longest is height, and the third longest or the shortest here is the breadth. The one thing that we know is the length of the cuboid is 15. Length is 15. This is fixed. Length is equal to 15. This is given to us, right? We have to find out the height. Height is equal to what is the question? So height will be definitely less than 15. If I look at the options, all the options are less than 15. So no elimination as such, right? Height should be less than 15. Why? The longest is 15. Height we know is second longest. Now what else do we know? The sum of L, B and H, all three of which are integers, is 3 more than half the perimeter of the square. Now square is involved. Square is involved here. So let's deal with it. 8.45% of what? 2000. Remember, total area of the sheet of the paper is 2000. So square 8.45% of 2000. 8.45%, I think we had calculated, right? It comes out to be 169. Simply 8.45 into 2 is 16.9 into 10 into 20 basically you have to do. So it comes out to be 169. So area of the square is 169, right? Area of the square is 169, right? S square equals to 169, which implies the side of the square is 13. That's the first step. Side of the square comes out to be 13, right? What do we know? L plus B plus H is 3 more than half the perimeter of the square. What is perimeter of square? Perimeter of a square is 4 into S, right? 4 into side. So 4 into S, 4 into 13 is 52. Now he says L plus B plus H is equal to 3 more than half the perimeter of the square. 3 plus half of the perimeter of the square. 3 more. 3 more means 3 plus half of the perimeter of the square. Half of the perimeter of the square is 26. 52 by 2, 26. 26 plus 3, 29. So the one equation that we know is the sum of all the three lengths is 29. Of course, we also know that L is 15, right? So we can find out B plus H. 15 plus B plus H is 29, which implies B plus H equals to 29 minus 15, which is 14. You should directly write this step, in fact. You should not write this step in the exam. Again, my explanation takes longer, and I'm doing that so that all of you can follow it. Otherwise, you know that this is 15. So B plus H will be 29 minus 15, 14. B plus H is 14. So that's one thing that we know. What else do we know about the cuboid? What else do we know? Nothing else. The other thing that we know is area occupied by the cuboid is 25%. What is this area? The surface area. Yes or no? The surface area of the cuboid is 25%. 25% is how much? 500, right? 25% of 2000 is 500. This was 169, like we had calculated. This is 500. 500, not 5000, sorry. So this is 500. Okay. Now, just deal with that equation to get the answer. What is this? Total surface area of the cuboid. Total surface area of the cuboid. What is total surface area of the cuboid? 2 times of LB plus BH plus HL. That is equal to 500. Now substitute the values. This is 250 anyway. And we know that L is equal to 15. If I take L common, what do we get? So it is like this. L times of B plus H plus BH equals to 250. What is B plus H? I think B plus H is 14. What is L? L is equal to 15. So substitute 15 into 14. 15 into 14, right? So what is BH? BH is equal to 250 minus L into B plus H. L is 15. B plus H is 14. 15 into 14 is 210, right? 15 into 14 is 210. So 250 minus 210 is 40. B into H is 40. B into H is 40. That's it. This is equation number 1. This is equation number 2. B plus H is 14. B into H is 40. Now I think you can verify using the options. You can verify using the options. Height. We are supposed to find out the height, right? So sum of two values is 14. The product of those two values is 40. I think 10 and 4 are the combination, right? 10 and 4 is the combination. I mean, I'm doing it directly. You can solve the two equations using the algebraic formulae. But basically, I think height is going to be 10 and breadth is going to be 4. Only these two combinations will give you these results, right? So 10 into 4, 40. 10 plus 4, 14. And we know that height is second longest, right? So height should be more. You may ask me a question. How do you know that height is 10 and breadth is 4? Why can't it be height 4 and breadth 10? Because we know that height is second longest. Height should be more than breadth. So more than breadth is, very clear, making it very clear that height is 10. So 10 centimeters should be the answer, option 5. All these are wrong. All these are wrong. I think we can also go by options if you want to, if you want to know how to solve these two equations, if you're not getting the solution directly. See, sometimes it happens when you look at the two values, when you look at the two equations, you can straight away tell what the two values are. Like here, 14 and 40. I mean, somehow it tells me that 10 and 4 is the combination. But let's say if you don't get this, if this is confusing for you, you go by options. What do? Assume that by the way, the other thing that to be noted is, at this step itself, I can say height should be more than 8, more than or equal to 8. Height should be more than or equal to 8. So 6 centimeters is eliminated in the beginning itself. You understand? Let me explain you how to go by options. If you don't want to solve the two equations, right? You can go by options. How? Let's look at it. If you are not getting this part of the solution, just go by options. How is that? Height is equal to 6. According to option 1, height is equal to 6. Can the height be 6 first of all? Because if the height is 6, breadth comes out to be 8. 6 plus 8 is 14, right? So breadth comes out to be 8. Can the breadth be more than height? No. So option 1 is eliminated straight. If the height is 12, breadth is 3. If the height is 8, breadth is 6. Sorry, if the height is 12, breadth is 2. 14, right? Total should be 14. Breadth and height total should be 14. So 12 plus 2, 14. 8 plus 6 is 14. 9 plus 5 is 14. Yes or no? What is given in the options is the height. What we have noted down is the breadth. So 6 and 8, 14, 12 and 2, 14, 8 and 6, 14, 9 and 5, 14. Why is first option eliminated? Because according to first option, height is 6, breadth is 8, which is incorrect, right? Height should be more than breadth according to the first statement. Second longest side is the breadth, height. Now, look at the other combinations. 12 into 2. See, I want B into H. B into H should be 40. 12 into 2, 24. No, it should be 40. 8 into 6, 48. No, it should be 40. 9 into 5, 45. No, I want it to be 40. So all the four options are eliminated. Hence, fifth option, none of this is correct. The next question is on your screens now. 1 minute for this. Just 1 minute for the next question. See what it says. If the height of the cuboid is same as the base of the isosceles triangle, find the semi-perimeter of the triangle. And he says use the information from the previous question. What is the previous question? In the previous question we found the height of the cuboid, right? What is the height of the cuboid? We got 10. So use that information. If the height of the cuboid 10, remember height of the cuboid is equal to 10, right? He's mentioned use the information from the previous question. Otherwise you cannot use. Remember, if this statement was not given, our answer to this question would have been cannot be determined. But very clearly he specified that use the information from the previous question. So he says height of the cuboid is same as base of the isosceles triangle. Find the semi-perimeter of the triangle. Find the semi-perimeter of the triangle. Quick. It's an isosceles triangle, right? You know what is semi-perimeter? Semi-perimeter is half of perimeter. So find out the perimeter of the triangle and then take half of the perimeter. You have 1 minute for that. Chalo, let's take it up, right? Let's solve this now. So the question, like you all know, says that the height of the cuboid is same as the base of the isosceles triangle. We have got the height of the cuboid from the previous question. He has asked us to use the information of the previous question. So basically, height of the cuboid is same as the base of the isosceles triangle. Find the semi-perimeter of the triangle, right? Now, triangle is what? 3%. 3% of 2000, right? Total paper area is 2000. Triangle has occupied 3% of that area. 3% is how much? 60, right? 3% of 2000 is 60. So basically the area of this isosceles triangle is 60. Now first step, we know that the base of the triangle, base of the isosceles triangle is same as the height of the cuboid. So basically B is equal to 10. B is equal to 10 since base is equal to height. Area of the triangle, which is half into base into height, is equal to 60 according to the pie chart. So from this, what is the height? See, half into 10, 5. 60, sorry. Half into 10 is 5. 5h equals to 60. H comes out to be 12. Right? Half into 10 into h equals to 60. So 6 into 2, 12. Height is 12, right? So height of the triangle is equal to 12. Now he's asking us to find out the semi-perimeter. For us to get the semi-perimeter, we should first know what the perimeter is. Understand that an isosceles triangle, the base is given as 10. We know the height is 12. Remember, in isosceles triangle, the height is the height bisects the base. It divides the base into two equal halves. In my diagram, it doesn't look like two equal halves. This portion looks to be longer than this one, but basically these two are equal. So if this is 5, this is 12, and this also is 5. And these two form a right angle triangle. These two triangles formed are right angle triangles. So if this is 12 and this is 5, this should be 13. Pythagoras theorem, right? hypotenuse square should be equal to height square plus base square, right? So 12 square plus 5 square, 144 plus 25, 169. This is square root of 169, 13. And this also is 13. You understand? I'm not writing that step now. 12 square plus 5 square equals to x square. X comes out to be 13. You getting it? I know the height and I know the base. The full base 10 is divided into two halves, 5 and 5. Now do the calculation, right? He's asking us to find out what is the perimeter of the triangle. Perimeter of the triangle will be 13 plus 13 plus 10. Yes or no? 13 plus 13 plus 10. 26 plus 10, 36. Right? 13 plus 13 plus 10. So 26 plus 10, 36. 36. But what is the actual requirement? Semi-perimeter. Semi-perimeter is half of perimeter. It is usually denoted by small s. Half of p. Half of p is how much? 18. Half of 36, 18. Option 2 would be the answer. The next question on your screens now. Try this. Interesting one. Here it says that assume that no cone is made of the given paper. No cone is made of the given paper. The other figures are made as given above. Then approximately how many hollow cylinders with no lids of radius 7 cm and height 1 cm can be wrapped from the remaining paper? Interesting one again. So he says assume that there is no cone. Right? Assume that there is no cone. So basically this becomes 0. There's no cone, this becomes 0%. So we will save how much of paper? 27.5% of paper. And also there is already some existing remaining paper. Remember, in the beginning of the question we had discussed, these are the shapes, plus there is some unused paper, right? Waste paper. So that waste paper and this, cone paper is saved now. Now from the paper that is saved now, we are making hollow cylinders. Hollow cylinders meaning what? Only the curved surface area of the cylinder, no lids. The dimensions are 7 and 1 respectively. So how many such hollow cylinders approximately can be made from the remaining paper is the question. So I've already given you the gist of how to solve it. Just play with the numbers. You have 1 minute for that. The clock's ticking now. Assume that no cone is made of the given paper. The other figures are made as given above. Then approximately how many hollow cylinders with no lids? Of course, I mean, this part of the question is redundant in my view, because when you say hollow cylinder, it is obvious that there won't be any lids. But anyway, he's being very specific, which is good for us. So how many hollow cylinders with no lids of radius 7 cm and height 1 cm can be wrapped from the remaining paper? Now remember, here remaining paper means what? You don't have to write this step in the exam, but remaining paper is what? Unused paper from the beginning plus the cone paper, cone area. There's already some unused paper and the cone area has been saved. How much is the cone area? See, 27.5%. I mean, I wrote 0% to indicate that this is saved now. But the idea is that cone earlier occupied 27.5% of the paper, the curved surface area of the cone. So 27.5% is how much? 550 we have calculated, right? So this 550 is saved. This is 550. 550. How much is the unused paper? I think this calculation we have not done so far. So we have to find out how much is unused paper. How do you get unused paper? From the total 2000, subtract all these values. Either do it in terms of percentage or the actual values. Let's do 616 is this, right? Calculations have been done already. You would have noted it on your books, right? 500. I'm writing it again because it got missed in the earlier questions. The 3% is 60, right? 3% is 60, and 8.45% came out to be 169. So sum of all these values should be removed from 2000 to get the remaining paper, unused paper. Yeah. So I'll write it here. Unused will be equal to 2000 minus this 550 plus 500 plus 169 plus 60 plus 616. How much is that? Now do the calculation very quickly. 550, I'll add all the hundreds, then add the tens, and then add the unit places, right? That's the easiest way to add the values, right? So 500 and 500 is 1000, 1100, and 600 is 1700. Then 50 plus 60, 110. 110 plus 60 is 170. 170 plus 10 is 180. 1700 plus 180 is 1880. And now add the unit places. 9 and 6 is 15. 1880 plus 15 is 1895. So 2000 minus 1895 is 105. This is 105. Right? Calculation is your lookout. You have to be very quick in that. So remaining paper is 105 plus 505, which is how much? 655. 655. That's it. So the area of paper that we have is 655. Now the question is approximately how many hollow cylinders of this radius and height, this height, can be made from this remaining paper. Now understand, when you say hollow cylinder, you are talking about a curved surface area of the cylinder. So how much is the requirement? Hollow cylinder, how much area would a hollow cylinder require? Hollow cylinder is nothing but the curved surface area of the cylinder, which is 2 pi RH, right? You understand, in cylinder, again this is all basic formula, but we are excluding the lids. Only this area is required. So 2 pi r times h will give you the area required per cylinder. So solve this first of all. 2 into 22 upon 7 into what is the radius? 7 into height is 1. Yeah, so each cylinder would take 44 centimeters square. So number of cylinders. How many will be the number of cylinders? Number of cylinders would be 655. Total area 655 available, divided by 44. I think 660 by 44 is 15, right? Approximately 15. Very close to 15. See, if the numerator is 660, 660 by 44 is 15. 655 and 660 are very close. So 15, approximately 15 cylinders can be made. Approximately 15 cylinders can be wrapped up in mind. 15, yeah, it should be close to 14.9 or something. 14.9, very close to 14.9. So 15 is the answer. Okay, the last question from this data interpretation set on your screens now. Quick. See what it says. Assume that the area of paper is increased by 60% and the radius of the cone is doubled. Now 5 hemispheres of radius 3.5 centimeter are made from the paper. What is the area of the paper that will remain in the end? Use information from the previous questions. So you can use information from the previous questions. What information? Maybe radius of the cone, right? Remember, we had solved for the radius of the cone in one of the previous questions. Which question is that? Radius of the cone. We got it as 7, right? In the first question, radius of the cone. So that information can be used, he says. Yeah. So radius of the cone is 7. This is doubled. So 7 is doubled means it becomes 14. I think that's the only information we need from the previous question. So solve this now. 1 minute again. The clock starts now. Assume that the area of the paper is increased by 60% and the radius of the cone is doubled. Now 5 hemispheres of radius 3.5 centimeter are made from the paper. What is the area of the paper that will remain in the end? He has asked us to use information from the previous question, which we have already used, right? Information from the previous question was the radius of the cone. 7. Now first step, assume that the area of the paper is increased by 600. What is the area of the paper? 2000. So new area will be how much? 2000 plus 60%, which is 3200. 60% of 2000 is 1200. So 2000 plus 1200, 3200. Or if you see increment in the area, what is the increment in the area? Increment in the area is 1200. 2000, 60% of 2000, which is 1200. Now, what else has happened? Area has increased 1200. Now, radius of the cone is doubled. See, here is the cone, right? The requirement of cone was 27.5%. We found that this came out to be 550, right? Came out to be 550 earlier. But now the radius is double. What is 550? Pi RL is equal to 550. But when the radius is doubled, the area requirement will also double. You are able to follow. For the cone, the requirement was pi RL, which was 550 in the initial case. But now the radius is doubled. In fact, this radius is not required. I mean, we know that this is 550. Now what happened? The radius becomes pi times of 2R into L. So it is twice of pi RL, which means 1100. So earlier what was 550 now has become 1100, which means 550 more. 550 more. Yeah. And then also remember the other information that can be used from the previous question is that unused area. Unused paper was 105. I recall that, right? Unused paper was 105 centimeters square. Now if you observe, how much is the remaining paper? How much is the paper with us? See, what is the area of paper that will remain in the end? How much is remaining in the end will calculate it in the end, of course. Now, what is the total net area available? Net paper available for hemispheres. Net paper available. What is the net paper available? Simple calculation. See, we already had 105 centimeter of paper available with us, unused paper. So this can be used for making hemispheres. Plus, we got an increment of 1200 centimeters square. So this also can be used for making hemispheres. But the radius of the cone was doubled, because of which the requirement of cone also got doubled. 550 became 1100. So 550 was already there, Now we are taking extra 550. So that 550 should be subtracted. You're getting it? This 1100 is what? 550 plus 550. So the first 550 was already there in the initial paper, 2000. The extra 550 requirement can be taken up from 1200. You're able to follow? So unused paper was 105 initially. We increased the area of the paper by 1200. But because the radius also was doubled, our requirement for cone increased by 550. So that increment should be subtracted here. It is an additional requirement, right? So we remove this 550. So what is the paper left with us to make hemispheres? 1200 minus 550, 650. 650 plus 105 is 755. Yeah. Now using this 755, we are going to make these hemispheres. You know what is a hemisphere, right? Hemisphere is half of a sphere. Half of a sphere. I mean, it's a 3D figure. I'll not be able to draw, but half of a sphere. And requirement for hemisphere, the surface area of hemisphere will be what? See, surface area of a sphere is 4 pi r square. So for half of the sphere, it will be 2 pi r square plus this circle, pi r square. 2 pi r square plus pi r square, 3 pi r square. You understand? Total will be 3 pi r square. So area for a hemisphere is 2 pi r square plus pi r square, 3 pi r square, 3 pi r square. How many such hemispheres are being made? 5 hemispheres. So let's say requirement for hemispheres. How much is the requirement? 5 hemispheres are being made. So 5 into 3 pi r square. These are all standard formulae, right? You have to remember this. Surface area of a hemisphere. Surface area of a hemisphere is 3 pi r square. So 3 into pi, 22 by 7 into r square. What is radius here? 3.5 is given. So 3.5 into 3.5. Do the calculation. This goes 2 times. This goes 11 times. Yeah. So 5 into 3 into 11 into 3.5. So 5 into 3, 15. 11 into 3.5. 11 into 3.5 is how much? I mean, just do this calculation and then subtract. He's asking us to find out how much of paper will remain in the end. There's one more step. Find out this value, then take the difference of 755 with that value. So 5 3s is 15. 15 into 11 is 165. 165 into 3.5. You get it? 5 3 is 15. 15 into 11, 165. 165 into 3.5. So 165 into 3 is 495. 165 into 0.5 will be 82.5. So 495 plus 82.5. That's like 582.5 minus 5, which will be 577.5. 577.5. Now, paper left in the end is equal to 755 minus 577.5. So that's like 155 plus 22.5. 177.5 will be the final answer. 177.5, option 2. I know this is complex in terms of calculation, but you got to do it, or simply skip. If you think this is going to take too much of time for you, you better skip in the beginning itself. Don't spend 1 minute, 1.5 minutes and then decide to skip it. If you have already spent about 30 seconds, 45 seconds, then you are better off completing the whole solution. But steps are simple. Understand, we increase the area of the paper by 1200. But our requirement for cone also increased by 550. So net available was 1200 minus 550 plus unused paper was 105. So overall paper available was 755, from which hemispheres were to be made. Requirement for each hemisphere is 3 pi r square, where r is 3.5 as per the question. 5 hemispheres, so 5 times of this. 577.5. Take the difference of these two to get how much of paper will remain in the end. Option 2 will be the answer.